Hi, I'm Nadia Lokot, Research Project Manager and host of the new eFELS webinar series, where we do a deep dive on software engineering related research so you can stay on top of trends. For those with us right now, please ask questions in the chat. And if you're watching a replay, feel free to drop a question in a comment section. So today we'll look at Developer Ecosystem, which is our annual survey. We've been doing it for 9 years. And in 2025, we based our report on answers of more than 24,000 developers. Check it out. We'll drop a link for the whole report in the chat. I'll go over some top insights, and I'm joined today by Product Manager from our go-to-market team, Ciara Byrne. Hey, Ciara, how are you doing?
I'm doing well, Nadia. Thank you very much for inviting me today. And actually, one of the things I really like about the Developer Ecosystem Survey is not only that it's one of the biggest surveys of professional developers, but almost half of those developers have 6+ years of experience. So a lot of the data you're going to show is also from senior developers.
Cool. Thank you. So let's start off with a topic that everybody's talking about, AI. What do developers really want from AI? So this chart here shows what it is that they're most likely to delegate. As you can see, there is writing repetitive code, searching for info online, and converting code to other languages. And unsurprisingly, the trend is to look for something laborious, time-consuming, so tasks that you can trust an AI to do. Ciara, what do you think makes these use cases so appealing?
Well, we know that there are two types of tasks that cause high cognitive load for developers. The first is lots of tedious but not very difficult tasks because they still cumulatively use a lot of brain power. And then the second type of task is difficult tasks, maybe unfamiliar tasks like writing code in a new language or in a new code base. So developers are very happy to delegate that first category of task to AI, and that's what you see actually on the left side of the chart here. The converting between languages is an interesting one because that is a core capability that you need for code modernization. In other words, converting, legacy apps to a modern language or to modern architecture, and that's a use case that we see coming up more and more for AI. For high value but more demanding tasks, what developers want is not automation but augmentation. And that's the kind of task that you see on the right-hand side here. And particularly for tasks that developers see as core to their professional identity, like systems design or like designing core logic, which again you see on the right-hand side here, they're quite reluctant to delegate those tasks completely.
That makes perfect sense. And it really aligns well with what we're seeing on this chart about benefits of use of AI when coding. So all these benefits, they're centered around speeding things up and productivity. So do you think these benefits apply to all developers?
We are actually seeing some very interesting patterns of usage that differ between junior developers and senior developers. So there is evidence from multiple sources that although junior developers use AI more, they use it less effectively in terms of productivity than senior developers. So there's some data that came out in Q4 from DX, which is a company that makes a developer intelligence platform. And they tracked 135,000 developers at more than 400 companies. And what they found was the more senior a developer was, the less likely they were to use AI daily. But staff engineers, who are the most senior engineers in a company, saved the most time with AI. While junior developers who use AI a lot more, they actually saved the least time.
Why do you think that is?
Well, AI coding tools kind of give you superpowers as a developer. It like turbo boosts the skills you already have, so you can do things faster and more easily. And it gives you skills that you don't have. So for example, you can write code in a language that you've never learned. So with senior developers, they see AI more as an over-eager intern who they have to supervise and delegate tasks to. So they use AI quite strategically in order to speed up and automate tasks that they already know how to do. They're also much better equipped because they have better judgment to evaluate the results of AI, the outputs of AI. What we see with junior developers is that they see AI more as a teacher, and it's possible that they're learning a lot, which of course they need to do at that stage of their career. but that doesn't show up so much in, time saved. So seniors use it more strategically to amplify what they can already do, and juniors use it a lot more to learn.
Well, we know what the benefits are for AI, but let's look at the downsides. Only 1% of developers did not express any concern at all for AI when coding. And at the top of the chart here, we see that concern about the quality of work that AI can produce is very important. Do you think it's justified?
Well, let's take a look at the top two concerns that we see here. The first is the quality of code. And high quality code is readable, it's maintainable, it's reusable. It usually has lower levels of defects and vulnerabilities. Low quality code is actually a form of technical debt, and technical debt slows down development. There is kind of contradictory evidence on the effect of AI adoption on code quality, actually. So Dora did a survey of 5,000 developers this year, which showed actually improvements in code quality with higher levels of AI adoption. This could be because AI tools can produce cleaner code more consistently for simpler cases. However, in that DX research, which I mentioned earlier, some organizations had improvements in code quality and other organizations had serious degradation of code quality with higher levels of AI adoption. So what that could mean is that there are differences in the development best practices and processes at those companies that are somehow affecting this, but we don't know exactly how that's working right now. The second thing you see on the chart is limited understanding of complex code and logic. To make changes in an existing complex, mature code base, that is an inherently more difficult task than just generating greenfield code. You have to understand the code, you have to understand the architecture, you have to understand possible implications of changes that you're making. So that's more challenging for L&M, and therefore the results for those kind of tasks can be a bit less reliable right now. There was another survey from Stack Overflow this year, which actually showed that developers' trust in AI outputs from AI coding tools actually fell in the past year.
Okay. What could be driving that? Sounds like a lot of distrust there. What could be the reason?
It could simply be that developers now have more experience with different AI coding tools, so they recognize their strengths and their weaknesses. But the biggest problem right now, especially for agentic workflows, tends to be solutions that are low quality or that don't quite work. So developers have to review them, they have to test them, they have to tweak them, and quite often they have to throw them away completely and start again. So the cognitive load is shifting from actually writing code from scratch to doing this kind of reviewing and testing and validation of the work that's being produced by AI. So developers need high reliability when they're doing high value work. And actually the traditional coding best practices like static analysis, test-driven development, code review are all really helping to validate and improve AI results.
We also saw privacy and security concerns on the chart there, and we know that it's the #1 reason for AI bans at companies and like a major area of concern for tech leaders. Does this come up at all in your conversations with customers?
It's huge for organizations. Again, there's a number of different issues involved here. So for software companies in particular, code is their core IP asset, so they want to protect it. For customers who are working in a regulated industry like healthcare or finance, they're also managing a lot of sensitive data, and they have compliance risks if that data or code related to that data is going outside of their security perimeter. So for that reason, a lot of customers want on-premises solutions or they want VPC deployment of AI coding tools. But I recently talked to a chief information security officer who is developing the AI guardrails for his company, and he's hoping that they will be sufficiently robust that he can actually move their on-premise deployments into the cloud. And by AI guardrails, what I mean is safeguards that ensure that AI systems operate safely. So one of the big problems also is security vulnerabilities in AI-generated code. AI has been shown to introduce vulnerabilities that mirror those which are added by human developers, which makes sense because all of these LLMs have been trained on, open source code, which have various security vulnerabilities. So a typical example is secrets in code, like hardwired passwords and API keys, which may then be passed to an LLM in the cloud. And it's a possibility then that that sensitive data will be leaked. So vendors are currently introducing different guardrails to filter out that kind of data and to address other security and privacy risks.
Are there any security concerns specifically related to agent usage?
With agents, tool usage is something that introduces new risks. So since the advent of MCP, it's possible to do things like tool poisoning, where a hacker can actually introduce malicious instructions into the metadata of an MCP tool, which is then used by an agent. The other issue is if you want to give agents more agency, so that they can, solve longer running tasks autonomously, the risk is also raised that they will cause some damage. So Claude Code, for example, just introduced secure sandboxes where your agent can run locally in the sandbox and it doesn't have any network or file access. So what that means is you can run the agent in what's called YOLO mode. In other words, you let it do whatever it wants. Otherwise, it has to check in periodically with the developer to ask for permissions to run certain commands, and that sort of negates the whole point of delegating to an autonomous agent. So that's one example of how, again, vendors are trying to provide more secure environments for agents.
So as we wrap up the year, let's look at some of the top trends of 2025. We've seen coding agents take off and becoming more and more popular. And we know that 70% of devs are likely to try one in the coming year as well. Can you provide some context about how developers are working with these agents?
We've seen the emergence of two major modes of working with agents. The first is collaborative, where you usually are working with a local agent, either in your IDE or maybe on the command line. And that's a bit like working with a pair programmer, except instead of with a human developer, you're working with an agent. It's very interactive. You may be working together on a plan for a solution. The second one is more autonomous and asynchronous. And the model there is more like you are delegating tasks to a junior developer who you will give smaller tasks to, but you don't quite trust. So you want to make sure that you verify the result at the end.
You mentioned command line agents. So another research of ours, AI Pulse, we saw that 14% of developers use at least one command line agent at work. Why are they so popular?
Claude Code in particular has been one of the big stories of 2025, and it seems to particularly appeal to JetBrains users because they can use command line tools like this, terminal-based agents. They integrate easily with your existing workflows and tool chains. So it has been very popular with developers using JetBrains IDEs. And that's one of the reasons that Claude Code is one of the agents that's now available from our AI assistant within our IDEs. But command line CLI agents seem to particularly appeal to more senior and experienced developers. I talked to the CEO of a startup recently and he said all of his developers are Gen Z and they're not really comfortable with the command line. So they were never going to use something like Claude Code. They all use Cursor. Whereas I've spoken to senior developers who are running like 5 Claude Codes in parallel, although that is still not so common. So these kind of CLI agents run locally, the same as agent mode in your IDE. But the other big trend that we've seen this year is for cloud agents. They're also known as background agents, and they run autonomously and asynchronously in the cloud. So you delegate a full task, and it basically solves that task autonomously.
Yeah, so we've looked at those in AI Pulse as well, and the survey data shows that those async cloud agent usage is really low. Like Google Jules and Devon, they're both around 0.5%. Why do you think that is?
Well, Devon and Jules are designed to be primarily or entirely used autonomously in the cloud. Like that's their major mode of operation. But our latest research on cloud agent usage actually shows that currently developers usually use cloud agents as a feature of a more general coding tool like GitHub Copilot or Cursor. So that could be one of the reasons. The kind of tasks that they are delegating to these cloud agents are smaller, well-scoped, lower value tasks. So the kind of things that we talked about earlier on the left side of our chart when it came to what people wanted to delegate, fixing small bugs, failed tests, stuff like that. But what we also found in that research is that developers are not entirely happy yet with the quality and reliability of the results that they're getting from these cloud agents. And they also complained about the lack of control over the execution of the agent and insight into what it's doing. Because when they work in the IDE, for example, in agent mode, they've gotten used to things like plan mode, where the agent first generates a plan and then you review it and maybe iterate on it. So the agent doesn't actually start generating any code until you have agreed that you have a good plan. That doesn't happen right now with cloud agents. You literally delegate a task and then it's one shot solution. They go off and the agent tries to fix it, comes back with a result, and then you have to review it. So because of that, you have slightly lower levels of trust as well. Probably as developers become more familiar with these types of agents and the tooling develops more, then the trust level will rise.
Thanks, Ciara. So I wanted to end this section about trends of 2025 with a note about JetBrains Programming Language Promise Index. So it's a composite score that our researchers have developed for each programming language. It combines historical growth stability, adoption, and user inertia. So this year, it's led by TypeScript, Rust, and Python. Ciara, do you see any reasons for these specifically being up top there?
So this links in quite well with the whole AI story because Python is the main language used in machine learning. So its rise has tracked that of the rise of AI, essentially. And Rust and Go are becoming increasingly important in AI infrastructure and in performance critical components as part of AI systems. So it's all part of this larger AI story.
I see. Let's transition to another topic. It's also top of mind in the age of AI, productivity. So in our research, we looked at both what impacts productivity and what companies are doing to improve it. So we found that developers say that both technical skills, like tools and how good they are, and non-technical skills like clear management, communication, and job design. So both of those are equally highly important for developer productivity and developer experience. So what makes them so valuable?
We know that non-technical factors like too many meetings or constant interruptions, which cause developers to have to context switch, have an outsized effect on developer satisfaction and productivity because it takes developers out of flow and they need to be in flow to do deep work. So having great tools, for example, but a dysfunctional work environment in other ways doesn't lead to high productivity. On the technical side, platform engineering teams often try to do things like automate error-prone manual work, like setting up development environments so developers don't have to do that. And also reducing development frictions, like long feedback loops. This is things like long build times or code review cycle times, for example, because those long waits also really have a big impact on productivity. Also, this improves ease of delivery for software teams, which is important for software delivery throughput. And I think it's one of the metrics that comes up later on.
Yeah. So this human factors and technical factors, are there any good examples where these two intersect?
I think code review is a really good example because it's a collaboration task essentially. And the quality of developer feedback is key to its effectiveness, but at the same time, reviewing is a demanding and time-consuming task for developers. So this year we saw a wave of AI code review features, including our own, that try to support human reviewers by identifying or organizing issues, as well as automating fixes of simpler issues. Another good example is onboarding, because there are technical factors involved, like setting up the new development environment for an onboarding developer. But there's also a lot of time usually taken from often more senior developers to help onboard new hires. And AI can actually really help to speed things up on both the technical and the non-technical side for that particular use case.
So let's look at this chart here. Shows disconnect between what technical leaders want to see and what companies are actually matching already. So here, the tech managers seem to want quite a bit more of fixing of the internal collaboration issues and reducing technical debt that what companies are currently offering. From where is this difference in priorities coming?
By technical managers here, I think we primarily mean actually team leads. So people who are actually directly managing developers. And one of the major findings of the developer ecosystem survey this year was that team leads are actually the primary drivers of improved developer experience and productivity within, according to, I think, about half of respondents. This was actually a bit surprising because even at the largest companies who have dedicated people to work on productivity, the burden still falls primarily on team leads. And team leads deal every day with the impact of these kind of non-technical issues like unclear communication or problems with team collaboration that it seems from this chart are still underestimated by organizations.
And why is technical debt such high priority for them?
Technical debt is also a day-to-day concern for team leads. As we discussed earlier, lower quality code and a lower quality code base is more difficult for risky for developers to work in. So it has a direct impact on their stress level and on their cognitive load. Too much technical debt can also slow down feature delivery, and that's often what development teams, their performance is measured on. We see actually AI can be very useful with maintenance tasks and helping to reduce technical debt. Things like refactoring work, bug fixing, migrations, and so on.
Let's look at how companies measure productivity. So on this chart, we see that some of the top metrics are developer engagement, developer satisfaction, deployment frequency, and developer sentiment. Why do you think these metrics are the most common?
Developer engagement, satisfaction, and sentiment are kind of all in the same area. They're really they're subjective measures of how developers feel about their work. One of the major frameworks for measuring productivity, the SPACE framework, actually mandates measuring developer satisfaction as one of the 3 dimensions that they say at a minimum you should be measuring out of 5 to have a rounded view of developer productivity. The next most common metrics that you actually see on the chart are from DORA. DORA is DevOps Research and Assessment Program. So DORA has been used for a long time by DevOps teams. And the metrics I'm talking about here are lead time for changes and deployment frequency. They're used as measures of development throughput, so how quickly you're moving. And there was another finding from DORA this year, which showed that higher AI adoption has improved software delivery throughput, which is a key shift from last year. This makes sense because teams can shift more code faster with AI.
We spoke a lot about importance of code reliability, but we don't see this in the metrics.
This is an interesting one because while clearly AI is speeding things up, DORA doesn't just measure throughput. It also measures delivery instability with metrics like change failure rate and rework rate. So that is like how stable is the release process, and rework rate also measures things like how many critical defects get into production. And unfortunately, in DORA's latest research, they found that higher levels of AI adoption lead to increased delivery instability. So you're getting higher levels of speed, but you're getting you're getting more instability at the same time. They also found that mitigation with AI features doesn't actually reduce the harm of instability by helping to fix some of those issues. So we still don't know all of the upstream and the downstream effects of this tsunami of AI-generated code entering code bases, or the effect of all of the other shifts being caused by higher AI adoption. So that is definitely something we're still learning about.
Yeah, let's see where these metrics fall short. We found that actually majority of developers either don't believe that the productivity metrics that their company uses accurately reflect their contribution, or they're just not sure. And only 22% said that they know how their productivity data is being used. We've also learned, and it's surprising, that 82% of devs are comfortable having their productivity tracked. So it's really not a question of them not wanting the oversight, but they actually just need greater transparency and clarity of the process. Why is this so challenging?
Software engineering is a complex technical and organizational process. And development productivity is therefore challenging to measure. What productivity means can also vary quite a lot, from team to team, from organization to organization, depending on what their business is, what their priorities are, what the size of the company is, and so on. Developers understand this better than anyone, and that is why they want more transparency and they want to have more input into how productivity is measured to make sure that what is being measured is actually relevant. One thing we know for sure is that organizations need to use multiple dimensions, measure multiple dimensions of the software delivery process, and use multiple metrics to see the whole picture, including subjective feedback like developer satisfaction, as well as the quantitative metrics like PR throughput, which is one that we're seeing more and more of.
Yeah, great insights. Thanks so much, Ciara. Now, to wrap up, if you had to choose one message for our viewers to take into 2026, what would that be?
For me, it would be, how can organizations move at AI speed without losing control over quality, security, and some of those issues that we discussed today? And also, what will be the software engineering best practices that we need for the age of agents? And what about you, Nadia? What's your top takeaway for today?
I do like the topic of productivity, and we spoke a lot about cognitive load. And as a project manager, I'm hearing that we could really use better workflows and maybe less meetings. Thank you so much, Ciara, for joining us today. I really enjoyed this conversation. And to our viewers, if you enjoyed this as well, please subscribe to future episodes and check out our other series.